Hi folks, we're going to take a look at the solutions to the September 15 quiz. Start with number 1 here. It says consider this polynomial function. The first thing they want us to do is state the degree. So we notice here that it's in factored form, so you're going to have to do a bit of work to figure out the degree. So you just have to look at the highest power of x that each factor contributes. Okay, so this contributes a factor of x, this will contribute a factor of x squared, this one x cubed, and there's another x. So essentially you just have to add up all these exponents. So exponent 1 plus 2 is 3, plus 3 is 6, plus 1 is 7. So we have an odd-degreed polynomial of degree 7. For the x-intercepts, no work to be done because it's already in factored form. Okay, so please don't forget that this factor of x does contribute an x-intercept. Means x, when x is 0, y will also be equal to 0. So here we have 0. This one tells you that x can be 2, x can be negative 3, and x can be 4. Okay, so 4 x-intercepts, but they have different orders. They didn't ask for this here, but it will come into play once we sketch the graph. Okay, so here for the end behavior, it's a odd-degreed polynomial with a positive leading coefficient. Okay, and so here we have as x approaches positive infinity, y will also approach positive infinity, and as x approaches negative infinity, y will also approach negative infinity. Okay, so now let's sketch the graph here. So I would like to see axes on here, and I would also like to see a scale. Okay, so please be sure, especially here on the x-axis, so here y and x, and since these are small numbers, I'll use scale just going up by 1. Now here for the y-axis, I guess I can always calculate the y-intercept. In this case here, since x equaling 0 gives me y equals 0, I actually have the y-intercept, so I can give the y-axis any scale I like. Okay, so I might as well go simple. Okay, so I'll start by drawing out the x-intercept. So here we have an x-intercept of negative 3. Here we have an x-intercept of 0. And then here we have 2. And we have 4. Okay, so we know we're starting at negative infinity. And at negative 3, we have a 0 of order 3. So that means at this point here, the function's going to look like a cubic function. Okay, so I really want to make sure I show that it looks like a cubic function. Okay, so now it's going to have to come back down, okay, and cross at 0. Since 0 is order 1, it's just going to go straight through. Okay, it's going to have to come back up. Okay, now here at x equals 2, we have a 0 of order 2, so we know that it's going to just touch the x-axis and come back down. And then at 4, it's just order 1, so we know it's going to go straight through. Now, one thing you should always do is make sure that your end behavior matches what it should be. Okay, so here we're starting at negative infinity, we're ending at positive infinity. Okay, that's it for number 1. So let's go to number 2 here. So again, they're asking us to sketch the graph, except here it's not given to us in factored form. Okay, first thing I do notice, it's a 4th degree with a negative leading coefficient, so I know the end behavior will be going from negative infinity and then back down to negative infinity. So let's try to factor this here. I don't really want this negative in front of the x to the 4th, so I think first thing that I should be doing to make my life simpler is to factor out that negative. So this becomes x to the 4th minus 13x squared plus 36. Okay. And here I should recognize this as a trinomial, so I'm going to factor it in a similar way as I would a quadratic trinomial. Okay, except instead of having x in each of these positions, I'm going to have x squared. Okay, so since leading coefficient is 1 here, nice and easy. Two numbers that multiply to 36 add up to negative 13, and that's going to be negative 4 and negative 9. Okay. So this is the first step in my factoring. I guess the second step, because we also had the common factor. But of course here I really need to recognize these both as difference of squares. So this factors as x plus 2 x minus 2, and then the second one is x plus 3, x minus 3. Okay, and here we see that this fourth degree polynomial has 4 x-intercepts, all of order 1. Okay, so they'll all go straight through. So again, let's draw our axes here. And just to show a little bit of precision, I can easily see that the x-intercept, which is just your constant coefficient, is going to be negative 36, okay? Which I'll only include on my graph at the end, because wherever the y-intercept ends up, we know it's going to be negative 36. So here I'll use, again, just go up by 1 on the x-axis, since I've got small numbers. So I have x-intercepts at 2, at 3, and at negative 2, and negative 3. And since negative leading coefficient, I know I'm starting at negative infinity, so it's going to go through, come back down, go through again. Okay, somewhere it's going to hit my y-axis, it's going to come up, go through, come back down, go through again. Okay, and so here's my graph, and wherever my y-intercept happens to be, hey, that's what I'm going to call negative 36. Okay, since I have no other point to take into account. Okay. Now, notice how I drew it so that it has this symmetry. Well, when I look at this equation, I notice I have an even exponent, another even exponent. This looks like it would be an even function. Okay, and in fact it is. If you were to check it out, you'd see that it is indeed an even function. Okay, so that's why I drew it as an even function. Okay, so that's it for this one. Let's move on to number 3. So here I'm given a graph and I want to find the equation. So we're going backwards here. So again, first thing I notice is I've got 3 x-intercepts. So I've got my x-intercept of negative 4, which is just order 1. Here, my x-intercept of negative 1 is order 2. And then I have an x-intercept of 1.5 or 3 over 2. Okay, and these are my x-intercepts. So let's write what a family of functions with these x-intercepts would look like. Okay, so I need my x plus 4 for my 0, negative 4. I need an x plus 1 for my 0 of negative 1, but since it's order 2, this is going to be squared. Okay, now here I could write x minus 3 over 2. Okay, but and if you did that, you wouldn't lose marks for the question, but you'd lose communication marks, because if we can write a factor using integers, we certainly try to do that. So we know that this is b over a, so ax, 2x minus our b value 3. So that's what the factor would look like. Okay, so this incorporates my x-intercepts and their orders, but of course I know I can have a value at the front, okay, without changing the x-intercepts. So before I calculate this, I'm just going to keep in mind that, look at the end behavior of this quartic. I know that I should end up with a positive number. So if I don't, it tells me that I made a mistake somewhere. Okay, so now I need to find another point that lies on this function, and the easiest one here would be just the y-intercept. So we know that the point 0, negative 2 lies on that function, and that's what I'm going to use to calculate the a value. So when y is equal to negative 2, x is equal to 0. Okay, and so now let's simplify the right hand side. So I have 4 times 1 is 4 times negative 3 is negative 12, and so a is just equal to negative 2 over negative 12, which is just equal to 1 over 6, and as expected the a value should be negative. So I don't have to insert, should be positive. I don't have to worry about inserting the sign at the beginning. If I do my calculations correctly, the correct sign should come out. Okay, so my function is 1 over 6 x plus 4 x plus 1 squared times 2x minus 3, and I definitely do not expect you to distribute this out to put it in standard form. Okay, that's it. Let's go to number 4 here. So number 4, you have this quintic divided by a linear. So when we're asking for the result, I know the quotient should be a quartic. Okay, thing to keep in mind here is that there's the x squared term doesn't appear. So remember, you have to add in the plus 0x squared. And I certainly hope everybody would do this type of division using synthetic division. Okay, so I'll set that up. So my coefficients here are 1, -1, -2. I have to add my 0 here. Okay, and then 3, -4. Okay. And remember that when I'm dividing by this linear term, my general term looks like x minus a. So that subtraction is already incorporated. So my a value, which is what I use to represent the linear term, is just going to be 2 and not -2. Okay, so here we just follow the procedure, bring down the 1, okay, then multiply 1 times 2 is 2, and add -1 plus 2 is 1, and again multiply, so that gives us 2, and add -2 plus 2 is 0. That actually worked out quite nicely. 0 times 2 is 0, so again 0 plus 0 is 0. 0 times 2 again, 0. 3 plus 0 is 3. And then 3 times 2 is 6. -4 plus 6 is 2. Remember that that last number always represents the remainder if it's not equal to 0. Okay, so what does my division result in? It results in the quotient represented by these 5 numbers. So remember, quintic divided by linear is a quartic, so this means that this is x to the 4th plus x cubed plus 0x squared plus 0x plus 3. Okay, and then we have to add to that our remainder 2 over x minus 2. Okay, and that is it for this quiz.